Take a look at some critical problems from this first formative assignment for right-angled trigonometry, the very beginning of trig. So what we're going to do is we'll start by zooming in on problem number 3, because I think it's probably the most tricky of the top. Like this one, you have a triangle, it's pretty easy. This one's tangent, so you know it's opposite over adjacent. This one I gave you secant. And so the first thing you want to do here is you want to realize that secant is not something we actually use a lot in calculations. It eventually develops into a graph that's important, but for calculation's sake, there's no mnemonic device for secant. The mnemonic device is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There's no secant in here. So you convert the secant into cosine by using the reciprocal. So you reciprocate this and then rewrite it as cosine. And so it would become cosine is equal to 2 over root 5. Now it matches the mnemonic device. Cosine is, and sometimes if you need to, you can kind of split the mnemonic device up by putting slashes here or something. But cosine is adjacent over hypotenuse, and now I can label a triangle. So I draw a triangle. You can draw whatever triangle you want. I label theta. You can put that theta wherever you want. That's the beauty of this. It will all come out to the same answer as long as you put stuff in the right spot. Mark your right angle and label your hypotenuse. And then adjacent to theta, put 2. And so then the question is, what is missing? Well, when you look at this, I'm missing this side. I'm missing the opposite. So I did opposite squared plus 2 squared equals the square root of 5 squared. And it's important to get away from A, B, and C. So I just label it opposite, adjacent, and hypotenuse quite frequently. And so opposite squared plus 4, that's that squared, plus 5, because the square root of 5 squared is 5. I subtracted the 4 and got 1 and took the square root, so my opposite side is now equal to 1. And now I'm able to do the whole problem. Because this is my opposite side, so opposite over hypotenuse is sine, so it'll be 1 over root 5. My adjacent over hypotenuse is 2 over root 5, but of course I already knew that here. And my tangent, which would be opposite over adjacent, is 1/2. So I go and write all this down, 1 over root 5, 2 over root 5, and 1/2. I immediately reciprocate them, so root 5 over 1, root 5 over 2, that was given, of course. And this reciprocated is 2. And then I have to multiply. I look at the very end and I say to myself, okay, well, I really need to multiply this by the square root of 5 on the top and the bottom, because there's this, a rule in math that you have to multiply by the root on the bottom to rationalize. So you get root 5 over root 25, which is 5. And then here you do the same thing, and you get 2 root 5 divided by 5. Okay, another one that students asked me about was this one right here. And so this one, again, the real thing that you need to do in trig is to write down your mnemonic device and then label the triangle based on what you're trying to find. And I just do alphabetical order. So if I'm trying to find A, this is the hypotenuse. Always do the hypotenuse first, because the hypotenuse doesn't change no matter what you're looking at. The hypotenuse is across from the 90-degree angle. And so once you know that this is adjacent. And so you can see how that's very important, because if you don't label the hypotenuse, you may say that's adjacent, but it can't be both adjacent and the hypotenuse. So label the hypotenuse first. And so looking at my mnemonic device, adjacent and hypotenuse is cosine. So cosine of A is adjacent over hypotenuse. I put my 6 and my 12 in there because I already labeled them. I reduce that. Remember, to find an angle, I have to inverse cosine. So if you inverse cosine of 1/2, you get 60. And of course, you can do that on Desmos or a calculator. To do B has a different perspective, right? So B still would be hypotenuse, but 6 is now opposite in the perspective of B. So opposite over hypotenuse is sine. So sine of B is opposite over hypotenuse. You put 6 over 12, you inverse sine, and you get 30. And of course, 30 plus 60 would add up to plus 90 would be 180. So you know you got it right. All right, another one that students ask me about all the time is this one. Okay, so I had to draw a triangle. So let me do that part, because I think that's really the part that really matters. One thing that's important for students to understand is that trig is all in the setup. It's all in how you set the problem up. So draw whatever right triangle you want. Okay, so here's my right triangle, and let's start labeling it. So Z is the right angle, so I'm going to label that Z. x is 75. You might want to label this more accurately because like this is clearly like smaller than 75. So I'm going to put x up here and call this 75 degrees. Okay, and then little x is 12, so that of course is across here, so this is 12. And it wants me to find y. Well, y must be here, which means little y is there, and then I start labeling. This is hypotenuse, always start there. And then I'm not given what y is, but I am given what's opposite it, right? So this is opposite. I don't know the hypotenuse, so I'm not going to use it, and y happens to be adjacent to that. So opposite over adjacent using my mnemonic device is tangent. So I did tangent is opposite over adjacent. Opposite is 12. Adjacent is y. I have to solve for y. So I multiply by y to get it free of the denominator. I do the same thing over here. And then I still don't have my y free. So I divide by tangent, right, to get 12 divided by tangent of 75. And that is going to give me the answer once I put it in Desmos. So why don't we go ahead and type this one in just to make sure, we know what's going on there. So all I have to do is type in 12 divided by tangent of 75. Just make sure you have it in radian mode. And if you use the graphing one, you don't know. So we do want to try to use the Desmos scientific calculator. It's a little more obvious with this. And if you were graphing, right, you would definitely want to use the other one. Okay. All right. So here's the scientific version, and you can see how it's in radian mode. So you get the wrong answer if you do it that way. So this answer doesn't make any sense. It's negative 28. So it's just so clear. Boom. That's the right answer. So don't use the graphing one for calculations. We'll use it when we do graphing, which is later in trigonometry. All right, so word problems, a couple of important things. In this problem, it does have an angle of elevation of 22 degrees, okay? But we have to remember that planes fly in the air. Don't put the 4 miles down here because planes don't fly on the ground. And once you do that, same problem. I'm given the height. I want the height that's opposite. I'm now given the hypotenuse. So in this case, I would be using sine. So you can use sine to figure out how high this plane is. This problem here is the whole angle of depression thing, right? So he stands on the edge of the ravine. It's a sheer cliff. He determines that it's 145 feet wide, okay? And then he determines the angle of depression. And it's just important to look at these key words, and they're literally exactly what we drew in our notes. So I draw an angle of depression, boom. I put 62.5 degrees in there. I draw this. I'm looking for the height of here. So from this angle, this is opposite. This is adjacent. And that is going to be tangent. So you're going to do tangent to do that problem. So in a little more detail, ones that weren't like in class, this problem is interesting because it actually involves 2 triangles. So I'll draw the diagram and I'll leave those triangles there to describe in about a minute here. So what happens is these 2 young ladies, they are at a building. In that building, they walk 203 feet away from the building. Okay, so they have this building here, and they walk 203 feet away, and they notice that on top of the building, there is a flag. So if they look up at the building from here, that's only going to give me the height of the building. Okay, so that one right there, they look up, and that's at an angle of elevation of 74 degrees. They get this height right here. I like to call that height 1. But then they look at the top of the flagpole, and look, they've made a separate triangle, right? So the separate one here is height 2, and that has a higher angle of elevation of 75.285 degrees. So if I take the tall triangle, which is the height of the flag and the building, and then I take the height of the building, if I subtract the higher height, if I subtract the lower height, I will get the flagpole, right? That's how I'll get this height right here, the flagpole's height. So I drew them over here. The first one is height 1 divided by 203. This is opposite of that angle and adjacent, so I use tangent. Same thing here. I just have a different angle of elevation. So height 2 is 75.285, that's still opposite, that's adjacent. I set them both up with tangent and solve by multiplying by the denominator. I type this in the Desmos. I do the same thing over here. I type this in the Desmos, and then I subtract them. So the building to the bottom of the building, the top of the building is 707.945 feet. To the building and the pole is 772.965. So if I subtract them, I get the flagpole. So I don't know. I think that's a pretty, once you see that problem for the first time, it makes sense. However, don't forget your units, and it really helps maybe to make it two problems rather than try to do it all in this one diagram. So the last one on here is also a two problem, and this one is great because it's kind of like a problem that you would see in regular algebra 2 in terms of it's actually a composite of two functions. It's really an f of g problem. So let's draw this out. You have a person, right? She is standing at a height of 140 centimeters tall. So her eyeball is 140 centimeters. So if she looks over here at a lamp post, that line of sight, as it's called, is still going to be 140 centimeters directly across from her. And then she looks up, right? She looks up at an angle of elevation to the top of the lamppost, and you start to feel like, okay, this is very similar, and it is. This is 14 degrees. But the problem is even though this is opposite, right, and this is adjacent, the problem is I don't know the width of this street. So that's what the second part of the problem is for. She then looks to the bottom of this pole, which has 140 in it because it's the same as her eyeball, and that angle of depression is 9 degrees. So here I have, in this problem, I have this is now opposite, and this is still adjacent to that one. So now I can use tangent, right, opposite over adjacent, to find w first. So I multiply by w to cancel it out, and I divide by tangent of 9, and I get 140 over tan 9, which is 883.925. This is the inside. This is the g. And now I can look at this problem and do another tangent of 14 degrees, which would be opposite. That's the height we're looking for. So height divided by width. I'm now going to plug this in to right here. Solve for this height, and then once I know that height, I can find the lamppost because it'll be 140 plus the height. So I'll leave that for you to do once you understand how that works. It's a very powerful problem. What this problem actually means, okay, again, it is a composite. You have to do one problem before you do the other problem. But these are real life problems, meaning if you were to take your eyeball height and look at a mountain, you could find how tall the mountain was without even walking to the mountain, climbing up the mountain, having anything to do with the mountain. All you would know is your own eyeball height. All you'd have to know is these angles. So you can find the height of a mountain or a pyramid or a tree without even being anywhere near it, as long as you have an accurate angle of elevation and angle of depression angle. And that's incredibly powerful because you can even do that on Mars with a rover. And literally they can do that knowing this basic problem. So make sure you finish that one up. It's kind of exciting when you think about how simple it is and how powerful it is.